How's it going, everyone? Today we're going to speedrun Python's built-in functions by going over 70 of them at an incredibly rapid pace. But before we dive in, I'd just like to thank Zed for sponsoring the channel. I really love their code editor. If you feel like trying out Zed, you'll find a link in the description box down below where you can download it for free. Otherwise, let's get started. We'll begin with built-in functions 1 to 5, which are used for type conversion. Here we have int, string, float, boolean, and complex. Although here I want to convert an integer to a complex, so I'll do that. When we run this, we will get the types that we specified as an output. If you use these built-in functions without any arguments, they will use the default constructor and give us back the empty value for each data type. Although to see an empty string, you might want to use the repr method. Then you can see those empty quotes. Moving on, we have built-in functions 6 to 13, which handle the creation and conversion of container and collection types. We can convert compatible data types to lists, tuples, sets, frozensets, and dictionaries just by calling the type directly on the object we want to convert. As an output, we will get the specified data type for each one of these. And we can do the same thing for bytes, byte arrays, and memory views, which are useful for handling raw binary data. When we run the code, we will once again get the data back as the type we specified, using the constructors. Note that you can use all of these constructors without arguments and they will give you back the empty default, with the exception of memoryview, which requires an argument for it to create a view of. Up next, we have built-in functions 14 to 16, which are useful for input, output, and creating chatbots. Starting with the input function, which allows you to input text into your script. Then we have the print function, which allows us to print values to the stream, or in human terms, display it to the terminal so we can read it. Right now, if we were to run this and say hello, it will take the input and give us an output. Also, if at any point you want to check what type an object might be, you can use the built-in type function, and this will give us back the type of the object. Now, by this point, you're probably dying to do a bit of math. So let's cover the next 5 built-in functions which make incredibly complex math problems a breeze. Starting with number 17, absolute, which returns the absolute value of an integer, float, or even a complex number. Then we have number 18, round, which rounds any number to the specified amount of decimal places. This function uses Banker's rounding for floats that end in 0.5. As you can see, when we run this, all the numbers ending in 0.5 are rounded to the nearest even. Now for built-in function number 19, we have a function that always gets me through the day. And this function is the sum function, which returns the sum of any numeric sequence. And finally, we have built-in functions number 20 and 21, which find the smallest and largest items in a collection. Alright, that's enough math for now. For built-in function number 22, we have enumerate, which allows us to create enumerations from collections. As you can see, when we run this, we get 0 Bob, 1 James, 2 Sandra, and 3 Luigi. Then we have the built-in zip function, which combines multiple iterables element-wise. Enumerate and zip are 2 examples of functions that return iterators, but we can also create our own iterators using the built-in iter function. To get the data back, we use the built-in next function. And now when we run this, we will get the next 3 values back. Python also has a iter and a next for asynchronous operations, but you'll learn about that yourself if you ever get into asynchronous code. It's time to pick up the pace because we have a lot of built-in functions to cover. Up next, we have any, which checks whether at least one element in an iterable is truthy. Then we have built-in number 27, all, which checks whether all the elements in an iterable are truthy. Number 28, pow, which is used for calculating the value of a number raised to a specific power. Number 29, divmod, a function that essentially combines the floor division operator and the modulus operator into a single call. So essentially this is the same as this. As you can see when we run this, we get 2 and 1, and we get 2 and 1 for these as well. It just combines them, which is quite efficient for some reason. Number 30, range, which is the easiest way to create a range of numbers in Python. And range returns a range object, which is very memory efficient. Number 31, length, which returns the length of any iterable. Number 32, eval. This function evaluates an expression and returns the result. Number 33, exec. Very similar to eval, but this function only executes code without returning the result. Number 34, id. This function returns the identity of any object. Number 35, callable. This checks whether an object is callable. A string cannot be called, but the sum function or the integer function can be called. Number 36, ord, which is short for ordinal. This takes a single Unicode character and returns its code point. Number 37, char, or character, which takes an integer that represents a Unicode code point and returns the character associated with it. Number 38, ascii, or ascii, as they say in English. This returns the string representation of any object, escaping any non-ASCII characters. Number 39, 40, and 41, which are bin, hex, and oct. These are used to convert integers to binary, hexadecimal, and to octals. As you can see, when we run this, we get the appropriate conversions. Oh my glob, that's already 41 functions. Let's continue. Number 42, map. This function allows us to map a function to an iterable. The result is a memory-efficient map object which can be materialized via list. Number 43, filter. This allows us to filter out elements using a function, and once again returns a memory-efficient filter object. In this example, I filter out all the elements that have a length of less than 4. Number 44, sorted. This function takes any iterable and sorts it in ascending order by default. Optionally, you can specify your own sorting key and whether to reverse the sorting. This function returns a new list. Number 45, reversed. This function is used to reverse a sequence. It returns a reversed object. To see the values, you can convert it to a list. Number 46, object, which is used to quickly create a new featureless object. A common use case for object is creating sentinel values. Number 47, slice. This function allows us to create reusable slices. As you can see here, I created a slice that grabs the first 3 elements and one that reverses any iterable. Now we can use it as many times as we like throughout the code. Number 48, hash. This function returns the integer hash value of an object. Number 49, dir, which returns the names in the current local scope. If you pass in an object, it returns everything the object can do. Number 50, vars. This function returns the names and values of everything in the local scope. Without arguments, it's equivalent to locals. Otherwise, if you specify an object, you will essentially get its dictionary back. Number 51, locals. Inside a function, it returns a dictionary that contains the current local variables. At the top level, it works exactly the same as globals. Number 52, globals. This function returns a dictionary representing everything that is visible at the top level. This can be called from within any scope to see the module's global variables. Number 53, repr. This function returns the representation of any object. Number 54, isinstance. Isinstance is used to check whether one object is the instance of another. Number 55, issubclass. This function is used to check whether one object is a subclass of another. A boolean is a subclass of an integer, so we can use that to test it out. And it will return true, since boolean is a subclass of integer. Number 56, super. Super is a special method used in subclasses. It allows us to use functionality from the parent class in a convenient way. Thanks to the super call, we were able to set up the parent class quite easily, so that we could use its functionality in the subclass. Number 57, import. This function allows you to import modules dynamically into Python. Number 58, help. This function tries to help you understand how an object works in Python. As you can see, when we use it on print, it brings up the print documentation. Without any arguments, it enters interactive mode. So here you can type in print, and it will bring up the documentation for that built-in function. Number 59, breakpoint, which creates a breakpoint for debugging. When we run this, it's going to run the code until that breakpoint. And we can press C to continue. Number 60, format. This function is used to format strings, although for a majority of cases, you might find f-strings to be more convenient. Number 61, open. This function is used for opening files on your computer. Number 62, static method. While this can be used as a function, it is more commonly used as a decorator to mark a method as a static method. And that just means that we can create a method that does not rely on the instance. Number 63, class method. Just like the static method function, this is commonly used as a decorator to mark a method as a class method, which is very useful for creating a constructor. Number 64, property. Just like with static methods and class methods, this function is now often used as a decorator to mark a method as a property, so that you can create getters and setters, which can be quite convenient. For numbers 65, 66, 67, and 68, we have hasAttribute, getAttribute, setAttribute, and deleteAttribute. To demonstrate how they work, I'm going to create a class called player. And we're going to create a player named Bob. Now we can check whether this player has an attribute named score. If it does, we can get the value associated with that attribute. And if that attribute doesn't exist, we can also specify a default value to get back. Then we can update the attribute using setAttribute. So here we want to refer to the player, use the score attribute, and increment it by 1. And finally, we have deleteAttribute, which deletes the attribute. Now, if we were to use vars on the player, we'd end up with a score of 1. Because here we changed that attribute, and here we deleted Bob from existence. And finally, we have two new built-in functions coming in Python 3.15, starting with number 69, sentinel, which gives us more readable syntax for creating sentinel objects, and number 70, frozen dictionary, which finally allows us to create a frozen dictionary. This means we cannot modify the dictionary once created. And that concludes our epic speedrun. I still recommend that you dive deep into each one of these functions in your own time, because there are a lot of features that you will only learn about from thoroughly reading the documentation. But for a speedrun, this was pretty fun. Do let me know in the comment section down below whether you learned something new today or whether there's a topic you'd like me to cover in a future video. Otherwise, with all that being said, thanks for watching and I'll see you in the next video.